everyone. Welcome to the monthly Beyond Zero Emissions discussion group for March. Firstly, we would like to acknowledge that we're meeting on the land of the Kulin Nations and pay our respects to their elders, past and present. We'd also like to thank the University of Melbourne Energy Institute as Zero Carbon Australia project partners for this great venue. BZE was started 10 years ago this year by a small group of people who were increasingly frustrated by some of the misguided efforts of groups that were promoting sustainability, and some of those solutions were thought to be actually harmful and not positive because the people making them didn't have sufficient scientific background. So BZE was started as the scientific end of climate activism, if you like. And so now it's grown into a greenhouse gas solutions think tank and research organisation. Our goal is to transform Australia from a 19th century fossil fuel based economy into a 21st century renewable powered clean tech economy. And it goes beyond the fossil fuel base. There are other aspects to our research that show how Australia is contributing to global warming and looks at all aspects of that contributions and how we can reduce them. Our projects include Zero Carbon Australia research, Repower Australia talks, media work, education programs and much more. We're always looking for more volunteers, so come and talk to us afterwards if you'd like to get involved. This discussion group is a forum for climate change solutions with presentations by experts in their field. It's held on the first Monday of every month, usually. Tonight our topic is insulation, cool roof paint through commercial building case studies. And as a BZE presenter, I've often been asked about insulation in homes where there's no access to the roof space or insufficient roof space for adequate insulation. I'm really interested to hear what Charles has to say. Efficient building envelope solutions were shown to be the lowest hanging fruit for energy savings, the most effective thing you can do to your home to save energy in BZE's Zero Carbon Australia Buildings Plan. These practical solutions are now being implemented around Australia in the spin-off Energy Freedom Project in the homes of everyday people. Charles Rendigs, the manager of Thermoshield, will now present energy efficiency case studies through commercial building projects. Charles has many years of experience, particularly in commercial buildings energy efficiency projects. Would you please welcome Charles?
Thank you, everybody. Thanks for coming tonight. There's been a few good updates recently, so I might have gotten myself into a little bit of technical challenges. I want to show you a few things that I've come across recently. I don't know if anybody was at the Climate Council's event at the Royal Children's last week. Silent Killer, Climate Change and the Health Impacts of Extreme Heat. And Dr. Leslie Hughes gave me some slides, which I might just keep off for now, but I'll show you later about the business as usual heat mapping for Australia going forward. It's even more extreme and frightening than I thought it was. We do a lot of work for Rio Tinto in the Pilbara, so we have some beautiful Pilbara shots I'll share with you. But we've been around a long time. We manufacture in Dandenong. We've really gotten into the whole bigger sustainability space around refurbishing roofs, because oftentimes in the past when I would get a Thermoshield opportunity, I'd find that the infrastructure was in such poor condition we couldn't just do the cowboy thing and spray it and move on. So we were getting into corrosion mitigation, waterproofing, and then we stabilized the substrate with the Thermoshield coating, which deals with the thermal bits and expansion and contraction, as I'll discuss later. This I literally just came across. I just wanted to put forth the concept that this is not a new thing. This is a thing in America called the Cool Roof Rating Council, and they actually just had their first issue come out of their newsletter. And I just decided, I couldn't get the logo off. They won't let you use it unless you're a member, so I just took the text. But they actually mentioned the Melbourne study. So I don't know if everyone knows about this, but the City of Melbourne, we've been working with the University of Melbourne since 2006, and Robert Doyle launched our product on ArtPlay in 2011. But now the city's mapped the rooftop, what they call, and I guess I call the rooftop potential. So there's, as you know, green roofs, cool roofs, photovoltaics. They're trying to look at roofs as an asset and how best to use them or protect them. So if you go to these websites, and I thought I had that on here, but let's see. I'm sorry. I have a piece of paper and a pen up here also because I'm going to go pretty quickly. If anybody wants any data, the slides, the accreditations, all that sort of thing, feel free to just give me your email address and we'll go through it that way. It's just not coming up on my screen here for some reason. And as I was just discussing with another gentleman, America's gone past the cool roof thing already to cool walls. So we do a lot of work in Boroondara where not only do they want performance and energy savings, but they want things to look nice, obviously. So the thing I had to explain to Robert Doyle when he launched our stuff at Art Play on Biro and Mar was it's not about reflecting visible light around, because that's not very interesting, otherwise we'd all be puddles on the ground or something. It's about the ultraviolet, the infrared, and that's really what you want to go after. So I just wanted to put this out there. Literally, this just came out as well, that California is already going past roofs to other aspects of the building envelope. We also do a lot of work in WA, as you can imagine. This is a power station, which unfortunately they needed more baseload power, so they refired this coal beast. But because of the hydrochloric acid, all the roofs were rotted out. And they also used to get fined about 50 grand a quarter for OH&S because the buildings got so hot to work in, so we did all that work for them. They got a quote for about $8 million to replace all the roofs, and we went in substantially cheaper and fixed them all up for them. Essentially, Thermoshield, it's not just a high-quality paint. It has a high volume of solids in it, and the solids are ceramics. And ceramics have very interesting physical properties. So if you think about why your car gets hot in the parking lot in the summer and the winter, it's because the sun comes in your window and it heats up the inside, and then it can't get out. So if you think about it that way, I try to always give practical examples because it gets very sciencey very quickly. And it doesn't look like polystyrene, by the way. I have some samples up here you can touch and feel later if you like. But that's an example of the spheres, and there's millions of spheres in this coating. And the special mixture is what you have to get right. And you have to put 2 coats on so that all the spheres cinch together. And it's actually fascinating because with this as the raw material and we get it at our factory, you put your hand through it, it's like a liquid. I mean, it's a very interesting physical process. More Pilbara. So we've been studied up and down. Everyone likes everyone to have their studies in Australia, so I have obliged, paid for a few of them. So we were all ISO'd up. As many of you may know, life cycle assessment's a big thing. I wanted to be the energy efficiency guy. I didn't want to be the heavy metal guy that killed all the chickens or pigs or cattle because there's something in my coating that's bad. So we got the ISO 14025 EPD, so that means, that's why the agricultural groups like us. We're doing some work in Bendigo now with GHD on chicken sheds, for instance. So you can collect water off our stuff and it's all good. CSIRO's done our fire testing. Melbourne University, we built 5 buildings in the Burnley campus in Richmond. It had a green roof, a white roof, one of my competitors' roofs, and I think just a Dulux roof. And we came out on top of the thermal discussion. That's why we got to do art play, and that's when the mayor launched what was supposed to be the cool roof policy, which maybe is still coming. And also, after the thermal discussion was completed, we worked further with, which was then DSE, which is now DEPI, and I went up to Suntech in Sydney and had them donate PV panels to put on the existing 5 buildings we had at the Burnley campus. Since we already had the capital built, I figured it was a good idea in Australia to prove that cool roofs make photovoltaics more efficient. So you'll see where I'm going with that in a minute. And Engineers Australia also calculated our like-on-like R values, but as I was discussing before, some of these tests and R values are kind of like 1960s, and they're about density, and it's all fine, but it doesn't really apply to us. So we're having some work done with the Australian synchrotron to do some imaging around how our coating deals with the full spectrum of light, because that's the critical bit. Right. Hello? Bobby. Was ist los? Oh, goodness. I apologize, I don't know what has happened. It's changing on my screen. Oh. Maybe I had a memory lapse. Just give it a moment. Okay. Yeah, there are accreditations. ISO, the EPD, CSIRO. We got GECA way back in the day when that was one of the only environmental certifications we could get, so we had that. We export to Malaysia, India, and Dubai, so we have our Dubai work. And this is what Engineers Australia came up with as far as our issues around emissivity, reflectivity, insulation values, all that. So that's why I'm saying if you want any of this in more detail, just let me know. This is the latest excerpt from, I was at the Living Building Challenge launch with Dominique Hess last week at Abbott's Collingwood. And this was the result of the PV extension study of the thermal study. So the red bit's the critical bit. So as most people know, PV likes light, but as some people don't know, PV doesn't like heat. So after 25 degrees C, PV efficiency starts going down. So what you want to do is keep the substrate and the area around it cool. And also, because we usually come in a white color, even though we're not only in white, we do reflect more radiant energy around as well. So what you really want to do is keep your roof cool, your substrate organized, so you avoid thermal shock. Then you put PV on it, and then that whole system, looking at the beast holistically, is a great way to deal with the thermal load on an asset, a building, a house, a chook shed, a refrigerated transport, and then generate the maximum amount of PV energy as you can. These are just things I come across which amuse me. I love companies that try to do the right thing, but they do that. This is more like it. The U.S. Coast Guard hasn't installed PV anywhere without a cool roof under it for 10 years. So they look at it as a whole system. It's not a decision. It's just the way they do it. That's the Art Play building, the Beer on Mar that we launched with the mayor. And there was PV on that building existing, which I've been trying to get the data off of for 5 years, but I have not been successful. So we're doing some other work with the city around some building now that they seem to be wanting to ramp up a greening of the greening of the city strategy and a PV strategy. We have a number of proposals in to fix up some of their assets so that they can bolt the PV life expectancy of 30 years onto them, and hopefully the roofs will have that same life expectancy. But we're just looking into the concept that putting PV on old roofs is a little bit dysfunctional, because when you're going to have to repair the roof, what do? So we try to be, the good guys, as opposed, as I was saying before, LEDs are really easy to measure. They're 83% more efficient than other downlights or whatever. You can measure that really easily. Obviously, we're a little bit weather dependent, and that's just a fact. So where you say that these are the results that we get, but just like with your car mileage, your mileage may vary. It depends. We get 3-year payback in Victoria oftentimes, and more like 2 in Townsville, for instance. So anyway, we got the best results there. This is just kind of a rundown of what you, if you think about it holistically, what you're trying to accomplish. I've been trying to deal with the Air Conditioning Association about re-specifying how buildings and the cooling is calculated by putting our stuff on an asset. So maybe you don't need a 40-ton condenser, you need a 25-ton condenser in our stuff. Or regardless, you're going to run it less, so the maintenance will be less. We actually have a site up in Harcourt, a winery, that we coded. The gentleman got a grant to build a shed, but he couldn't afford the $100,000 to run 3-phase to it. So he says, Charles, I can't pay to cool it, so I need you to coat all of it. And we coated it 6 years ago now, and he's never needed air conditioning. We just stabilized it, and he stores his wine in it. Just crazy. Extending roof life, yep. We meet Section J requirements, and we think it looks good, and you'll see why. And this was the linchpin. It took a couple of years of research with the university, but reflectance is a lovely concept because there is a little bit of heat and visible light, and that's all good. But if you're working on only that principle, once the asset gets dirty, which everything does, you have no more tools in the toolbox. So what they found is that we have high insulation properties. So that's what gives us kind of the advantage around the place. We do a lot of work for the Queensland Caravan Association members, and we get these lovely emails from the Grey Nomads in Alice Springs saying, Charles, my van's totally red, but if your stuff still works, we're sleeping cool at night, it's all good. So it's we get great results. And these are their findings in the report. And again, I have the whole report. If you're interested, I can email it to you. But obviously cooler in the daytime, but warmer at night. So obviously in Victoria, we heat and cool. It's not Townsville. So some naysayers around the place say, oh yeah, cool roofs are all great, but they negate the benefits in the winter. Again, as I'll always honestly say to you, it's a tool in the toolbox. So depending what you use it for and where you use it, you just have to be aware of what you're trying to accomplish. But that was the proof that it's an insulator, and that's what, again, makes it more interesting. Some of the data I'll show you, I hope I can get all my graphs and things happening. The other thing I deal with, for instance, I just did a presentation to Parsons Brinkerhoff. I deal with a lot of mechanical engineers because we do change the way buildings operate. A lot of air intakes off buildings are on the roof, so you're oftentimes taking in 80-degree air and then throwing energy at it to cool it. And then, ironically, then you put it in a steel box with minimal insulation, and then you transport it across the roof to shove it down the side of the building, and then you heat it up again. So the system doesn't seem to be that sensible if you think about it. So the results we get, which I'll show you, is we bring roof temperatures down, oftentimes 40, 50 degrees. So the air intakes, you have to throw less energy at it, less running time of the condensers, and obviously less thermal intrusion from the outside. So we kind of deal with it in a holistic, as I say, like a trifecta approach. And these are some of the roof temperature differences we get. And this is again from the University of Melbourne report. We did the Croydon Leisure Centre some time ago, and that's the savings they got. We love leisure centers. They're great for public relations because everybody loves their leisure center, but they have two problems. They're energy pigs, and they have chlorine, moist, hot chlorine. So the Ashburton pool we just did last year, it was going to be a $20 million refurbishment project, redevelopment, and they're going to take the roof off. We went in, we did the outside of the building for thermal reasons, and then we did the inside of the building for corrosion. The purlins, the supports, the inside, everything, and the whole redevelopment went to $14.5 million. And now they get the warranty, they get everything. But they didn't have to tear the whole building apart, and the downtime was reduced, and happiness all around the town. So leisure centers are, if you think about ammonium nitrate sheds, that's really toxic. Moist chlorine is the worst, it gets into everything. We won a $45,000 government voucher from the Victorian government, and we're doing some regional work. And they wanted something rural, so we're up in, I actually had a guy up there today in Bendigo. We're doing a chicken shed comparison. So the preliminary results, we're getting the energy data and all of that sort of thing. But just as a quick aside to show you how sometimes I get measured around things, and as I say, it's a tool in the toolbox. For chickens, I get measured less around energy and more about mortality. So less dead chickens, we win. At piggeries, I get rewarded for more pigs. Because when the pigs are more comfortable, the pigs make more pigs. So we are getting energy data, but with agriculture, it's always interesting because the asset owners have different motivations around things. So that's the chicken shed. We wanted to get identical environment, if you will, so no shading and nothing to get involved in the study. When we started, that was the temperature of the shed exterior. And after we coated it, and we recently reformulated our emulsion, we got higher quality ceramics. That's the results we got. So if that heat is not building up on that substrate, it's not transferring in. And the gentleman that owns this shed is he's really hysterical. He said he got up on the coated one, and he said it was so hot he couldn't get up on it. I mean, because it was re-radiating the heat off so much, he couldn't physically get up on it. That's the Ashburton Library. I think I'll blast through some of this stuff. So yeah, that's the whole offering we're offering now. And the beautiful thing, as I mentioned, I haven't mentioned it, we have a 10-year warranty. But because we're an acrylic or a water-based solution as opposed to a polyurethane or a 2-pack, etc., in 10 years, we can renew the warranty just by cleaning it and putting another coat on. We don't have to strip it back to the bare metal and start all over again. Because as I said, I have some samples up here you can touch. It builds up really well, so you just get more performance out of it. Just a quick cross-section of clients. As I've mentioned before, we do everything from beehives to airports. So being business development manager, my verticals are very horizontal. When my phone goes off, it could be anybody. But the interesting one there, actually, DeBordeley, we did their tanks, and Bress was where we did that shed without any energy requirements. Cardinia, we did a container that had their cogen unit in it, so it had rust issues and vibration issues and heat issues. And Ardent Leisure, I'll show you a case study on that in a moment. So obviously, I'm trying to work with hospitals and schools. I actually have a meeting with the Alfred pretty soon because unfortunately I had to spend some time there. I had my gallbladder out, and all their roofs are rusting tragically. And I mean, you can imagine a hospital having to rip their roofs off to replace them. So I'm trying to work with them. I finally got in front of the head of capital and infrastructure to do our system with it. Deal with the corrosion, deal with the waterproofing, deal with the thermal, and then hopefully with their building management system measure the whole experience. Again, this is a roof plumber kind of dynamic and a building dynamic, but thermal shock is a serious issue. My wife bought us a puppy some time ago, and I thought the dog had some kind of seizure disorder because every morning she'd be in the back extension where we have this big clip-lock extension, and she'd be looking up and jittering and flipping out, and I'd say, "What's wrong with the stupid dog? What the hell's going on?" She could hear the roof moving before anybody else could. So as the sun came up in the east, she would hear the expansion and contraction, and then I would hear it at 11 o'clock, and she'd hear it at 9 o'clock. I'm like, damn God, she's smarter than I am. But that's how you get leaks. So the minute you put a roof on, it starts disassembling itself, just by nature, and especially in Victoria when you get your 5-degree mornings and your 30-degree afternoons, it's just physics. And because I've had to hire all these plumbers to do all the work, as I said prior to my Thermoshield extravaganza, this is just a fact. It's in the plumbing manual. So it's a little bit distressing, really. I guess that's good for us, but this is why I'm trying to deal with John Thwaites at the Australian Building Codes Board and the National Construction Code to put this kind of technology in as a tool in the toolbox around it. Building envelope, dealing with assets, future-proofing, all that sort of stuff. Because it's just a shame that we let the outside in. Again, this is just stuff you see that we just couldn't put our Thermoshield on over just naturally, so I'm actually in the process of buying a company in WA that has a compatible rust converter that actually works, unlike some Bunnings products, and is compatible with our system. So we see all this kind of stuff. That was the Ashburton Library before we got at it. Major energy consumer on High Street. They actually bent the roof over that top purlin, so all of that was cracked and leaking. And the red there is our rust converter. So it's also an Achilles heel kind of telltale. If our Thermoshield coating fails, you'll literally see red. So we own a drone. Everyone should have a drone. But it's really useful when you're in our business because we can do drone inspections and pre-project report, analysis without actually getting up on stuff. So we repair everything and do it properly. Again, all that was just cracked and it was tragic. And we come across these roof plumbers, dissimilar metals. Again, another sciencey thing around how corrosion starts. You need air, oxygen, and water, and then if you have dissimilar metals, it just accelerates. So we see this kind of nonsense all the time. So we put in fiberglass patching, so we really cinch up the asset, so it just takes care of business. And that's the before and after. We think it actually looks good. So many people are saying, oh goodness, they're going to have a white roof in Ashburton, oh gee whiz. Never heard anything about it. But the Dandenongs, ironically, have an adverse white roof policy for some reason. Now, bear with me. I won't go too much further into that because corrosion, I know you guys probably want to talk more about energy stuff. Yeah, this is our new favorite extravaganza. This is Townsville. This is that ardent leisure client I mentioned. This is a bowling alley. Again, all the sexy things I get to do. We call this roof porn. This building has no insulation in it. Low roof over obviously the hung roof. And Rick, the engineer there, approached us and said, we need a solution. So he is a really good guy, and I love engaged clients because I want to be able to measure hopefully 12 months prior to our application, and then 12 months post, so we can see in different latitudes and longitudes and different kinds of buildings, because again, it's all different, what kind of results we can contribute to energy efficiency. So he has given us login privileges to his building management system. So we can capture data at any time. And obviously, as I'm saying, you kind of have to get the principle of the thing. I know this is in Townsville. It's consistent weather. It's good. But this is the principle of the thing if you can go with it. So obviously that's our drone shot. We do thermal, external pictures prior and after, and then we do entire project videoing because we found risk people, assurance people, asset managers. When you say you're going to work on someone's roof, it's like, yeah. Nobody's ever going to check. So we actually videotape our whole process for people, and they love that for insurance reasons, for a lot of reasons. Excuse me. So it's a 15-day project, and we had the building management system cranking along, and Rick was nice enough to put a temperature sensor in the roof, and that's the reduction we got after the project was completed. So, as you can imagine, this is that type of building. It's a supermarket. It's it could be anything. So there's obviously other Achilles heels to it. But as you see, we've also done the condensers and the ductwork. So that whole surface now is taking in 32 degree air as opposed to 80. It's transferring it efficiently and insulated. And that's the energy bit, because Rick now wants us to do 40 buildings for him. Ardent's a pretty big operation. So we always try to bounce our stuff off bureau data where we can. And in this graph we show we have almost a 2% rise in temperature year on year, and we still had a 14% reduction in energy. So we're really happy with these kind of case studies, and as I said, latitude, longitude, windows, double glazing, all the stuff we talked about. I mean, it's all part of the system. But this being this kind of building is a really great example, because otherwise that roof is just a radiator. I mean, it's obvious. So that was the net of it all. Yeah, so we love the Ardent Leisure one. This is, just so you know, we had our engineers Australia do our R-value calculations, and it came in 3 kind of separate documents. So if you put Thermoshield even on an inside wall, and I have clients that have done the inside of their house with this, you get an R2.2. If you put it on a roof and it's a cloudy day with some wind, not that hot, you'll get a 4.3. This is the one, kind of the Townsville one on a clear day, on a real stinky day, you get an R6.3. So again, the principle of the thing is the more heat you throw at this stuff, the better it performs. But again, it's not working on the principle of R value like resistance. It's not letting the heat in the building first and then fighting it. It's fighting it from the outside. So we're fans of people that have insulation already in their structures, because we're just going to make it perform better. We're not trying to put the air conditioning guys out of business. There's going to be, as this report shows, I mean, extreme heat is going to be a thing. So air conditioning is still going to be required, but we're just saying, let's use it less and more efficiently. This last one is actually, just because it's a local example, I want to show you this one. This is in Abbotsford. This is actually our Telstra dealer across from the Carlton United Brewery. So we use Nearmap a lot, as you can imagine. As you must know, Nearmap, kind of like Google Earth, but much more au courant, and you can time-lapse it. So as you see, building managers, they let things rust, and then once you see the rust starting, it's amazing how it accelerates. So we started this project, all 4 of those condensers were going, and when we finished it, only 1 was going. And this guy is also an engaged client and is going to monitor his energy for us. But look at that. Plus they're going to have to replace that roof. So look at all the assets and the plant they'd have to disassemble to get at that roof to replace it. I mean, it would just be shocking, expensive and disruptive and tragic. So unfortunately for them, on this job, our rust converter is actually an expensive thing, because it really does work, and it's acrylic, and it's... So the most expensive part of this job was the refurbishment. So the red is our, again, as I said, the rust converter. So again, if the Thermoshield ever failed, if we did a drone inspection and there was a red coming through, we'd be able to see it. So we do all the duct work. The first coat, condensers, second coat, and this is the whole project in a nutshell. So right across from the Carlton Brewery, right on Church Street, right? So that's before, that's the rust converter, and that's after. Sorry. So it's just a really great system, so now you don't have to throw the roof out either. So that's why we're adding that into our sustainability story. So we're definitely all around energy efficiency, but we've kind of taken it to the next logical level around expansion and contraction reduction, photovoltaic enhancement, and reducing the thermal load on the asset, whatever it is. And one thing I was going to try to show you, has anyone gone to that My Climate website, the thermal web from CSIRO. It's something the city launched. I think I might. Because we're trying to wrap this into, because you can really see it. Oh no. It's all right, it's not. So this is an interesting tool that they've developed where you can actually see the urban heat island effect. Oh, good, it's all good happening. So this is where that whole study came into play, where we were looking at roof potential, because there's multiple ways to deal with the roof. I mean, you can deal with it from a PV generation perspective, you can deal with it from an infrared and ultraviolet rejection perspective. Obviously, asset owners are not really keen to put green roofs on things because they're expensive and they weigh a lot and they need a lot of maintenance. And don't get me wrong, I work with the green roof guys at the Burnley campus and they're all great. And I wish them the best. It's just that it's really a lot to manage. And the other thing that I kind of bang on about a little bit, unfortunately, and everyone will have their opinion on this, is adult behavior change. With my stuff, you don't have to turn it off, you don't have to turn it on, you just have it. So I like that about it a lot as well, because my wife lived with me, she still leaves every light on in the house, and I don't know what to do. So this website is interesting, and you can actually see the roofs that we've done from here. Let me see if I'm lucky. We're doing more of the St. Kilda Town Hall soon. Carlisle Street. Carlisle? All right. And you can zoom in and see particular places. So that's the St. Kilda Town Hall. So when you go to urban heat island, you can see the difference in temperature around all sorts of assets. So this is still, I think, in beta, and I don't know who actually has access to it, but again, the principle of the thing, wouldn't it be great, and we're actually working with the city on this, to do a postcode, to do Laverton, to do, pick one. Or even do a straight strip in Brunswick, North Melbourne, with all the old buildings and old roofs, and actually measure it, and you can visualize it. So this is the kind of stuff we like to do because it kind of validates my existence on some levels. This area here, we did all that about 6 years ago, and ironically it was done by an applicator who we fired, so we're redoing that for them at no charge, but then we're doing all of this and all around, hopefully before the season turns this year. This is an interesting tool in the toolbox because you can see, your neighborhood, you can see all sorts of things. But it's a validator. It's again, as I say, we're all about the data and the transparency. So this is another tool that we use to show people. I was with an architect at the Pixel building a couple of weeks ago. And he got onto this thing in his boardroom on the big screen, and he was playing with it, and he thought it was terrific. And he was zooming in and finding this really, really hot spot. And and he was playing with it. I didn't do it. And he was zooming in, and it turned out what he was zooming in on was an oval. Because the Aussie grass, it's short and it's kind of not really green. It's not like Connecticut. It's a different transevaporation dynamic. So it even heats up, pretty extremely. That's why, as much of a fan of Barren Wood as I am, greening the city and all that, that's all good. I would much rather have a tree next to me than that bowling alley thing. Absolutely. But since all the city trees are coming out pretty soon just because of their life expectancy, I'm all about what's the mitigation strategy? What's the plan? Because we need to the urban heat island effect. In 2009, those fires killed 174 people, and 400 people just died around the place just that week in general. So that's why this report, which maybe I can get up some of the data in there. If you haven't seen it, it's pretty frightening. Outstanding. So this is from the Climate Council. This isn't mine, but literally I just launched this last Monday at the Royal Children's. So you can just take from it what you will, and I can make these available as well. They're very nice to email them to me today, just because I thought it was relevant, because I'm a big picture guy. I mean, yes, I love to do buildings and all that, but it's all about all of us, and schools and hospitals, and if this is the kind of stuff that's happening, we need a lot of tools in the toolbox, and I think we're just one of them, but it's getting pretty silly out there. And this lady, Leslie Hughes, was very brutally honest, and we were talking at Paris about 1.5 and all that sort of thing. We're already past 2. So if we're going to be realistic about this, we need to get onto it. And as we were discussing, it was another record year last year. And this was an interesting just dynamic around a small change in the average and a large change in the extremes. So I'm not apologizing, but sorry for getting off my kind of horse, but this is the big picture, and this is one of the things I'm trying to help with. So the Climate Council, this was just very timely because it was literally last Monday. And these are some of the other beautiful statistics which I really didn't want to hear. Triple the odds of heat waves. So it's we have to get on with it. So this is why they say I'm trying to deal with the building code board, and because right now the only people I can deal with are the innovators, the ones that think outside the box, who think the building code of Australia definitely needs an update, which it definitely does. And as I say, we're a tool in the toolbox, and hopefully there's more tools in the pipeline, and we're all going to go forward and prosper together. But I have a 12-year-old daughter, and I'm a little scared. So I think that might be all I have. Unless anybody would like to see any particular case studies around schools or anything in particular. Wine, we do wine storage facilities, chocolate factories, heritage chocolates we've done, all sorts of things. So that's about the right time. Any questions?
With a white roof, what's the reflectance like for people?
It's a really, obvious and good question. I think that's why the Dandenongs, the Shire up there doesn't want them for probably just political reasons. They just don't want to deal with it. But I just did a house that had 6 kilowatts of solar on it in Lower Templestowe, on a hill with a house behind them. And the gentleman, lovely guy, called his neighbor and said, "This is what I'm doing, is it okay with you?" And he said, "Yes." Because I said, "Rob, I can tint it if you want me to." Because like at the Ashburton Pool, part of it you can see from, part of it points one direction, part of it points another. So we did the majority of it in white, and then we did the rest of it in surf mist just to take it down a little bit. But then we added our infrared pigments and you get the same performance. So as I say, it's not only about white. It's easier for us not having to tint. And as we were discussing before, tinting is an opinion. People go, "Oh, it's not too dark, it's too light, it's too," we like white, we get the best performance out of white simply. But obviously, as I say with Borondara, they wanted the Q Rec Center, some of the walls to be green, on the facade, and that's fine. It's just more effort and a little bit more money because we have to work harder to do it.
Does it reduce the performance light around to green? So?
Well, if we don't put the infrared pigments in it, we lose about 6%. So if we just tint white Thermoshield, a white-based Thermoshield, we lose about 6%. But as I say, now that the global market for infrared pigments has come down so much, we're happy to put them in, almost at cost neutral, just to keep the performance up if you want to go darker, for architectural reasons or whatever.
You got photos of the tinted buildings there?
Oh, I will look for one. Do you want to ask your question, Ellen?
Yeah, I just had a question. You mentioned on the chook ships there was, you couldn't get up on the thermoshielded roof because it was the air coming off the thermoshield was too hot. So
Well, I think he was being a little bit dramatic, but he was literally saying it was so hot. It was uncomfortable to operate up there.
Okay, so how does that work with the air conditioning system? So you were saying that the air conditioning systems are actually seeing a lot less heat coming in,
Well, chook ships don't have air conditioning.
obviously.
Right.
The same principle would apply to it.
No, I see what you mean. But it's pushing off the heat. So when you stand above it, and you're a human and you're an absorber, you feel it. When you're just an air intake, it doesn't affect it. It doesn't draw the heat in. As Rick the engineer at Ardent Leisure yells at me about because he loves it so much. It's crazy. Sorry, just because I came across this. This is the Ashburn pool, so this is the different tints. And as you see, we did the ductwork on this side, but they take their air in from the side, just as a fact. But that was a big job that we did. That was tinted. Oh God, Belmont, I think I did one. I mean, it's just, we could do any Dulux color. So it's really, I'm not going to say it's not interesting, but one we're doing really soon, 2006 Eastlink headquarters. They say whenever it gets hot, their air conditioning explodes and nothing works. We have to call in emergency mechanical repairs. Our energy bills, they sent me their energy bills. You would not believe their energy bill. And that is a 2006 architecturally built headquarters, which I'm all sure you've driven by at one point. And when I went there for my meeting on my iPhone looking at I could not believe it was a black roof. I mean, the stuff we see is really good fun.
So you're going to do black colours with it, perhaps?
Well, we've been asked to do electric cars. So we do have an emulsion for electric cars because electric cars are great and there's range anxiety and all these kind of things. I'm actually working with a guy, you're not going to believe it, he's ex-40 years Holden. His name is Laurie Sparks. Couldn't make that up. And he said, Charles, everything's good. Oh, there's Tim Fro. Who asked me about Tim Forsey? There he is. He said, we got the battery sorted and it's all good, but the air conditioning is what kills us. So we want to find a way to take care of the heat ingress into an electric car. One thing I did want to show you, I hope will work. This is my best roof porn, so if you're offended by porn, turn it around. This is the Kew Recreation Center. We did this project for Gorndar as we tend to. We've done the entire pool area, but they did a big Ingley solar install on it. So this is what we think is the way to go, especially with big infrastructure and vast roof spaces. There was a budget issue, so we haven't finished it all yet. We have to go back, but and we have to get the ductwork done. But that's the principle of the thing. If you get my meaning, like that's what we're going for. Because people ask me about don't solar panels shade the roof and all these kind of things. It's like, in certain circumstances, yes. Look, even on this install, look at the degree angle between this side of the roof and this side. But keeping all of this cool is still beneficial. And then, as I said, now the longevity of the roof is guaranteed. So as I said with Aaron Wood from the city, don't put 30-year life expectancy on assets that have a life expectancy of 16 months. I mean, why would you do that? I mean, how are you going to fix that roof if something goes wrong? So fix up the asset first, then put cool roof on it, generate more juice, and there you go. And that's a white job again, sorry. But again, as I say, color, we can do any Dulux color. So I just did a house in Belmont down Geelong way, and they wanted green, so we did green. But we brought it up. We just brought it up farther than you would normally. And this is Toorak Road, right in Camberwell Road and Toorak Road. This is an accountant's office, which was one of my favorite projects because accountants count stuff. So they had their energy bills before they did the solar and before they did the Thermoshield. And now I get their energy bills with that installed like that. And they are very happy. It's Jim Moray's accounting firm. Oh, and as I said, any asset. This is the Cardinia container. It was all rusting and falling apart and that kind of asset, and they wanted to keep the heat out of it because the motor was having heat issues or something. So no other real color ones that I can think of offhand.
Question. Going back to that question earlier about I think that question from this woman here was about the technical question regarding the wavelengths at which radiation is re-emitted and how that impacts on the immediate atmosphere, and just whether that's a shorter or longer wavelength, whether it can actually re-radiate right out into space, or is it absorb? I mean, and in terms of the heat island effect.
Yeah, exactly.
Yeah, exactly. Well, how locally contained is the heat that's radiating in these rooms?
I get asked every question in the book. I absolutely love it. I actually just came across a document today. I was actually going to bring it because it was actually around all of what you just said, the modeling around. Again, as I said, kind of like I'm trying not to be clever and put heavy metals in my stuff and get around something by being derby about something else. Okay, great. So we're doing this. What are the effects broader? And the modeling around it, you can imagine. I mean, climate modeling, all the modeling that we're doing in our world. It's not easy, and it's different everywhere. And if you give me your email, I will try to find that for you because what this article did was essentially explain why that's so difficult. And even I just kind of go, it was even too much for me. I mean, because we understand that we're dealing with one asset at a time, and isn't that great? But how are we affecting the area around it?
Overall, I understand the modelling overall for the greater globally and for an immediate would be complex, absolutely. But we can infer from the basic data which you can get from the laboratory work. This is what wavelengths does it emit at the surface when you put certain wavelengths directed at the surface. What does it re-emit at?
Well, this is the work that we had done research around emissivity and reflectivity.
Yeah, fantastic. Thank you.
Yeah, sorry. It's
That's awesome.
I come at this. Everybody comes at this a different way, and it's all good. It's just I can usually find everything I need to find. So that was our emittance, and that's our reflectance. But as I say, the Cool Roof Rating Council in America, they only deal with those two parameters. So the beautiful thing about us is, if we put our spheres in it, we're an insulator. If we don't put the spheres in, we're this. So you want to, again, as I say, you want to have the right tool in the toolbox. Because we don't only manufacture Thermoshield, by the way. I mean, we do other things, and I have 2 chemists on staff, and we're always doing R&D and things like that. But that's that bit.
So just one significant thing might be is the wavelength that's absorbed by carbon dioxide, for example. If it's not, then obviously it should have go back to space. So that would be of some of the benefit,
Oh, sorry. Exactly. That's why I'm working with the synchrotron.
Right.
We have a $300 million toy in Clayton And I have Monash students across the street, PhDs that want to have a play. And I have David Cookson, who's the head of Beamline Science there, who's fascinated by this. And I met him at the Small Technology Cluster Drinks down at Scoresby last December. And he said, we have to re-engage in 2016. I want to know more about this. So we're trying to get to that point so that I can tell how much percentage of all the wavelengths under controlled methodology, because as we all know, and we're in a university setting, the methodology has to be correct, right, or it's irrelevant. So I only like to hang out with smart people, so I figure for the synchrotron, there's not many more smart people than that. So we're dealing with them to see how I can visualize this for the layman, for the scientist, for the builder, for the building code, to explain, with not using R values, C values, U values, the traditional ones, how we assist in dealing with the building envelope around light.
So with R values, you're comparing with bulk insulation to the roof.
Yeah, that's what that James Fricker from Engineers Australia did, like on like, trying to help us explain the performance, but with something at 500 micron. Sorry, do I have to wrap it up?
No. I was going to ask you, relevant to one of those questions, a parapet roof. Does a parapet roof, does that tend to trap the air on the roof surface and not allow? Is it undesirable to have a parapet? That's where you have the walls extending up above the roof line, and consequently you probably have less circulation of the air flows.
Well, this is why I was at the EBM PAPS Open Day at Box Hill Institute last week, because ventilation is a very important part of the building. So we work with partners, especially around buildings where we can get beneficial night cooling in, and then you kind of reset the building for the day, and then our stuff takes that peak off during the day. Because you kind of want to fight the beast at all fronts, but I don't like those whirly-birds that just spin randomly all year round, because it's out of control and it's letting you get cold. It's random. So I'm dealing with some fan companies that have intelligent fans with baffles and timers and humidity sensors and things, because you want to get condensation out of buildings as well. So again, I don't want to be that clever guy saying, gee whiz, I sealed up your building so well, now it's all rotting from the inside because it can't breathe. So the buildings have to breathe a little bit, obviously. And I hope we all understand that. As much as and I went to the passive house thing up here the other week, it's all very interesting, triple glazing, and it's all good, but you can't make things a vacuum. I'm working on a guy's house down in Corio. The building window schedule is $400,000, and none of the windows open. And he's an HVAC contractor. He's doing all his own air exchange and monitoring, and So again, as I say, everyone attacks this a different way. I'm doing all of his roofs and all of his walls, and he wanted me to do his driveway. Getting back to the urban heat island effect. Why can't you do my driveway? Jesus Christ. So I get asked everything. It's beautiful. I love it.
So there may be a parapet type design if you were to build a new building, would be a desirable thing, and you'd have a sort of a fancy.
No, it's fine. Passive ventilation, or forced, what I call forced passive. Like, you can have those whirly things, but you got to be able to control them a little bit more intelligently than just the Bunnings $50 thing, because you're effectively putting a hole in your roof. So, especially in Victoria, we're trying to accomplish different things at different times of year, so you just can't have things randomly spinning. So like the Bendigo Stadium I went up to, the whole top around, the whole perimeter of the roof was rusted, and they wanted me to deal with it, and I said, well, I can't. But I said, you have to redesign the building so there's ventilation. There was, they put thousands of people in this building, and there was no way for the condensation to get out.
You mentioned chocolate factory. Do they use a copper surface? Or,
I don't.
I was just wondering why you mentioned chocolate factory. There's special requirements for insulation.
No, well, exactly. Wine, that's why we do a lot of work with things that are temperature specific, like chocolate turns crappy when it goes off in the wrong color, wrong temperature, sorry. Wine, the same thing.
We'll do the Capri one at Ringwood, ex-Capri.
Where I was working,
Canterbury Wines is a good one, yeah.
you know the chocolate factory or the old chocolate factory in Gibb Street Colony? It's become, it's been...
All I know is Le Bon Ton on Gibb Street, and I love that place.
Now, it was designed, it was a huge chocolate factory, and I noticed from the aerial photography that this was 10 years ago, 8 years ago, and I looked at the aerial photographs of it, and it was right near where I worked, so I was curious, and I noticed it was all green. And I couldn't figure out why it was green, whether it was rust, whether it was corroded copper, or whether it was just leaf material and vegetation.
Well, we're dealing with Mount Scopus.
Chocolates is 2 years heritage. Is that what you're asking?
Yeah, I'm sorry. You're yes. So this is another engaged client that we like. Yeah, they wanted. Is this the right one? I think it was the right one. He wanted us to do half of his place because he wanted to see how it performed. This is why I love engaged clients. They're absolutely hysterical. So we did the 2 coats of Thermoshield. I think it was, the finished goods warehouse, right. But he has the other warehouse as well, but it's, I don't know, it's raw material, so he wasn't that concerned about it, and he wanted to be on temperature sensors in both. Look at all those condensers banged onto that beauty. I think we have, yeah, here it is. This was this project. So again, as I say, your mileage may vary. So 65, not 87 like in Bendigo, depending on what kind of day it was, but we got it down to 31 degrees. So that's a 52.8% surface reduction. So that's the chocolate factory. Oh, yeah, and this was a different day. See, 4 degrees higher. And the roof did get up to 85, then we got it down to 33, and that's a 60% reduction. So we love doing these kind of things. As I say, I love agriculture and food and all that sort of thing because obviously we just keep throwing energy to stabilize all our food all over the place. And this is the internal temperature. We hung, we hung temperature sensors at different depths to get different readings. I think this one and Canterbury wines. So we wanted to show, because obviously we have all different kinds of buildings, like the bowling alley when the roof is right here is one kind of opportunity, and when you have big sheds, it's a different opportunity. So we did that measurement for that one. Yeah, so they're engaged and they're sending us our bills, and I think we still have temperature data loggers in there as well. Because as I say, Victoria's a different beast, and I'm always going to get asked about payback and all that sort of thing, which again, I never guarantee anything because it's a bit variable. But if you get the principle of the thing and you have a heat issue, as I was discussing, well, you have a heat issue. You can feel you have a heat issue. You have energy bills, so we try to attack it. Sorry, yes?
I have a concern about the way you're measuring some of these changes, because you're saying a 38% decrease or a 60% or whatever percent decrease. What's the zero on your scale? Is it 0 Kelvin? Or is it 0 centigrade? Or is it 0 Fahrenheit? Because they're all different temperatures. And what are you measuring zero from for your percentage changes?
Zero from?
Celsius.
Yes, I mean...
It's all centigrade.
Yeah. It's zero would be no difference between the before and after.
In Kelvin temperature?
It's Celsius.
We're in Celsius.
30 Kelvin units.
Yes, sir.
Can you give some idea of the cost, say, per square metre of the most basic house, nearly flat, coloured-on roof?
Right.
Is it possible to give a rough...
No, absolutely. This one just tends to be a good example because, as you can see, it's flat, easy to get up on, no dramas. We also do economies of scale. We do a lot of interesting proposals for councils that only want to do bite-sized bits, but we do it all at the same time to save money. So it goes between $25 and $30 a square meter applied. So that includes pressure washing, because we have to get down to a good clean substrate first. And then 2 coats of Thermoshield is the most basic job we do. Like that's the one we do day in and day out. People that want it to be more trafficable for whatever reason, like we're doing a lot of work for Deakin University now where they have a huge plant on their roof and they have people traipsing around the place. They wanted it to be a little bit more durable, so we put 4 coats on. So we can do about 500 square meters a day. If it's a clear, sunny day, it dries. It's water-based acrylic, so it goes on pretty quick. And we can build it up, and the more we build it up, just the more durable it gets. So the price depends, and of course that doesn't include any corrosion mitigation or roof works, but if we just had to jump up on a roof, a virgin roof that just needed a little thermal assistance, and as you say, we don't need lifts, like at Deakin I have to rent this lift that's costing me 12 grand for 9 days to get up on this crazy roof. If there's no other, hardware costs, it's about 25, 30 bucks.
So 25, 30 per
Square meter.
Would you expect to improve the insulation at the same time to get maximum effect?
Oh, I mean, we're a fan of insulation, but as we know around the place, some assets just aren't insulated. I have been called to brand new office buildings on the train line in Paran, and they say, Charles, we don't know what's going on with our building. We know it's brand new, it's this rating and all these kind of things, but I think we need your stuff on the roof. Can you come have a look? I said, just give me a ladder and I just need a broomstick. And they don't know why I asked that, and they give it to me. And I cannot tell you how many roofs I've been up into in a sunken roof, and I pop up one of the roof tiles, and there's no insulation in the roof. And it's a brand new building.
Where's the building codes?
Yeah. I mean, there's 2 issues. There's the building code, and then there's enforcement. And I'm pretty sure I don't have to tell this audience how I feel about that. I mean, there's carrot and stick and all these things, but if nobody's checking, nobody's checking. So
is there a building code for commercial buildings?
No, there's I mean, there's a standard for ducting insulation. There's they're all pretty average nationwide. I mean, I was at a Melbourne University thing a couple of weeks ago, the Carlton Connect initiative. They had the people from the city of Zurich coming over. They look at us and they say, look at that space under that door. Look at that window. I sit speaking German and I get excited. How can you live like this? Leaky buildings. So our standards are pretty lax, well, not lax, but they're low standards to begin with. And then there's nobody traipsing around the place checking anything. So I get dragged into beautiful opportunities for me because nobody did what they were supposed to do in the first place.
I mean, you can't build a house without appropriate insulation.
Well, homeowners are a little bit more engaged.
The design. You have to have the design.
You have to put it in, but nobody checks.
Yes, sir.
Does the angle of the roof, can you apply it to any angle? Any house roof, which seems to be fairly steep?
Oh, God, do I have that picture? One of my favorite projects was Sovereign Hill. Okay, everyone knows what Sovereign Hill is. So they can't just bolt a condenser onto it. It's a living museum. And they had the apothecary, if I remember properly. My God, do I have a memory. And they said, well, Charles, we have the apothecary, but we have one stretcher on the property, and every year we have to carry the apothecary lady out because she passes out because of heat. And it gets to be 50 degrees in this building. And I said, okie dokie. And they said, well, Charles, you just have to make it look like an 1850s rusty roof. So I had to get past their Heritage Design Committee to get that job done. And we did, and they've never had an issue with it since. And we kind of did it in a gray, and we bashed it up a little bit. And God, I used to have that picture. It was a class, and it also answers your question because it was, it was steep. It was stupid steep. So yes, that was a bit of a problem because that required scaffolding and all sorts of safety stuff. But so it sticks to, and as I said, we did deboard these tanks, vertical, tanks. So we might have to edge prime things like deboard these tanks. We had to edge prime because they're stainless steel. So obviously not a lot of stuff sticks to stainless, so we have to etch prime certain things. So that's why pricing is always, you have to be very specific. If it's just something I can jump up on and I don't have to do anything special to it, it's relatively cheap, and Board and Dollars never push me back on price. But if there's stuff like that, it's just labor. It just has to be done, and we just want to do it properly. And I'm sorry I don't have that picture, because it was a great picture of that building with a donkey in the back. Yes, sir.
How does your business or you interface with the air conditioning, industrial air conditioning? Are you in conflict with them? Or?
Well, I go to the Melbourne Forum every quarter, just to stick it to them. I mean, I'm the disruptive New Yorker. I don't have anything to lose, and Rio's my biggest client, so I don't care. I mean, I care because I care, but I don't need their business care. So we actually just had a Living Building Challenge meeting at ERA on Elizabeth Street, and I told them, I'm trying to dock with you guys. I mean, I want to work complementarily, systemically, holistically with all industries, to get the best outcome for clients and the environment. I mean, God, did that sound like a pitch? Jesus. But, seriously, I mean, how about you use a little bit less gear, throwing gear at everything, and do something that's what I call affectionately passive-aggressive. We put it on and it's kind of passive, but the way it deals with radiation is pretty aggressive. So wouldn't that be a great solution? So in answer to your question, I tried. Phil Wilkinson, he sees me coming, he gives me a big smile and a handshake, and he walks the other way, because his stakeholders want to sell you the 50-ton condenser. And the building code's not going to tell them to do anything different. And they wouldn't enforce it anyway.
Can you ask the question you asked me? How do you achieve change in the insulation building regulations? What are the pathways? Who are the people? Who are the organisations to achieve radical or semi-radical and desirable change in insulation standards? That's the question.
Peter, it's. I mean, I'm from. Apologies, from New York City. I'm a straight line guy. I thought Thermoshield was going to be one of my little companies. I build it up to a $20 million thing, flick it off, get on to my next thing because I get bored. And I'm still trying to deal with weights and getting this into the building code. I'm suicidal. It's stupid. Again, as I say, it's not a silver bullet. I'm not trying to say that saves the world and give me $1 million. It's a tool in the toolbox, but if you don't even acknowledge it as a tool, my respect level for the system kind of goes all shitty. Because, I'm just one part. This is just one little itty-bitty piece. But it also, as you can imagine, the surface area around the place, it's pretty applicable. It's pretty relevant. It's not brain surgery. So, to answer your question, I'm still trying. And John's a good guy, and I deal with Anna Scarbeck at ClimateWorks and the Clean Energy Finance guys and Arena. So I'm trying to bolt all my stuff onto all their projects, especially the City of Melbourne, because they paid for that study. And now they're going the PV direction, which is perfectly fine. I'm not taking it personally. But we're complementary to that. So why aren't we all talking to each other? But I get these condescending emails from the City of Melbourne saying, oh, Charles, we know about your stuff. People are always trying to sell us stuff. We tender things out. We have no use for your stuff. Maybe you should talk to these people. And they don't even understand that they've already paid for the study, but they just never did anything with it. So it's like my, God rest his soul, father-in-law. He worked at CSIRO. Cabinets full of IP. So I'm the guy, the disruptive guy. I talk to every university. I'm doing work with Swinburne, University of Melbourne, Deakin, all of them, trying to get this silo stuff gone. There's only 24 million of us. We don't have time to be doing the same thing across the street from each other. So excuse me, I get cranky, but that's why I deal with the synchrotron. No one else is using it for anything. You're killing me to go down there. Of course, I got to kick in 10 grand, but I don't care, that's right. Jesus. Just to show the difference, and also that I'm engaged. That I'm not a cowboy. I'm so transparent, I don't even have any clothes on. Yes, sir.
Two questions. Your product going to be available ready-made on steel strips for housing, and secondly, can it be applied to tiles, the non-metallic tiles?
I've talked to BlueScope, I've talked to Colorbond, I've talked to Jerry Ryan at Jayco, just to give you 3 examples of companies that have been around for 40 years. They just like to do what they do. They think of me as a value-add, outside, external thing.
Customers need to go and ask for it.
Yes. but the groups, especially Queensland, I mean, I ship 1,000-liter tanks and B doubles to Queensland. I mean, they just get it up there. Tiles. I do have a tile picture. As you understand, I am an insulator, I'm not a reflector, right? So tiles, by their very nature, and you can help me probably see it, tiles in their nature move. They're supposed to move, so you can shove your antenna wire through them and do whatever the hell else you do. So what we do a lot of are 1950s concrete tiles because they started to powder. People have rainwater tanks, they don't like, they start to powder, and obviously they're thermally disastrous regardless. So we try to...
Thermoshield on tiles.
You're all hired. So the answer, getting back to what does it apply to and what does it stick to, tiles. Beautiful, no problem at all. It's just, you have to understand that if you're going to do work and rip up tiles to put in a whirly bird or whatever, we want to have to come back and seal it up again. So there's no reason we wouldn't do it. It's just, and we can do terracotta, it would be the next question, that's perfectly fine. What else do we do here?
Roughly, what are you looking at in terms of pricing? We talk to a lot of people about the energy freedom bit of BZE, and the energy, you're talking to people who own perhaps a 1950s brick veneer with terracotta tiles, that sort of thing, and their question to me is how much?
Well, I mean, that's the thing. I presented to Steve Bygrave, and I've had Matt Wright at my house, and I bought a sand and heat pump from him, and we all get each other, and it's all good. And Richard Keach, also, very smart guy, who I respect. And I didn't think I'd be able to convince him, because I thought he knew everything. And I don't mean that in a bad way. I mean, he's a really bright guy. But he's been recommending me to clients just like what you're talking about. The ones that are just insulation defined, they just don't have anything. And there might be low income, there might be a lot of things. And they're not going to be able to go up and tear open their roof to put in bulk insulation and do that kind of stuff. They're just not going to do it. So yes, we are that kind of solution where, again, we'd still like more insulation. New builds, all good. A fan of all of it, but we just want to start dealing with it from the outside. And if I can get those kind of results by just jumping up on something and having a bit of a spread for $25 a square meter, and I've gotten it down to like 11. I did 3 Woolworth stores in Tasmania. We were down there for 3 weeks and just banged them all out. So we'll help anybody. They take beehives to airports. Bees are a great example. They're great at moderating their environment, but when you get those peaks, even they can't deal with exhausting the excess heat. But the funny thing we did with the test with the beehives is we didn't coat the beehives. Because what are we? An insulator. So the heat we would keep in as well. So we had to build little structures over the beehives to keep the radiation off the substrate of the actual beehive, let them ventilate the beehive, and we just kept the penetration from happening, but from afar. That was my favorite example from agriculture, because obviously bees, we love bees, we need bees, and Jesus, bees. So that's that example. I need a beer. Helen's Hill Winery. Anyway, any other questions?
Yeah, I was just wondering if pollution or anything has an effect on the coatings once they're up. Does it affect the longevity?
As I said, we do ammonium nitrate sheds.
Yeah.
At Verve Energy Power Station, hydrochloric acid.
Power stations you can do. Yeah.
I'm working with a guy who bought the control building for the Morwell coal-fired station that they've decommissioned, and he now has a carpet cleaning company in it. It's like going back to 1940. It's just unbelievable because it has all the original gear. Like they have the coal pit, the conveyor belts, this control building, And then the power station, I mean, it's just far out. It's scary in Morwell, but I hope no one's from Morwell.
Oh, yes, they are.
It just broke my heart. I mean, because it was just so, it just is what it is.
Well, that's why I asked.
No,
we
you're
do get a bit of pollution in the air.
Yes. So he is, I put in a big quote for him to do his roof because his building is built like a shit brick house. It's beautiful, but the roof is shot because of all the hydrochloric
Yeah,
acid.
got a lot of nitrous and sulfur.
Exactly. Yes, sir.
The main energy costs for housing, domestic housing, is in winter, and that's the first time I've heard it talk just concentrated on summertime costs. Now, is that different in commercial buildings? Is that why you're concentrating on keeping the heat out rather than keeping the heat in?
No, we're doing both. But as I say, we're doing it at different levels. And that's my trouble in sometimes discussing it, but you guys are smart. You know, as I say, the exterior application, big stinky hot day, we re-radiate a lot of that heat because we're having a lot of heat thrown at us. In the winter in Victoria, when you're just trying to keep a room ambient, well, we stop that heat too, but it's just not that aggressive. So if you plane half of a room with Thermoshield and the other half without it, and you go boom, boom, you'll see the difference. But it's not going to be full 50 degrees. So it's an insulator is the answer. I mean, Broad Street from DSE, now Deppy, he did the inside of his house with it, and he monitored his air conditioning and heating for me for 4 years and showed me the savings. So, and he's happy to talk to anybody about it. And as I said, Harry Trudell from University of Melbourne, I just delivered stuff to him over the holidays for his house, for the inside. So it depends where your Achilles heel is, and it depends what you're trying to accomplish, and you have to have realistic expectations. Because I also did a bathroom in my house in Camberwell with Thermoshield, mostly because the bathroom had no ventilation and I needed anti-mold capabilities. And it was an unheated thing, but I put a heated floor in and I wanted to seal that space to make it as comfortable as possible. So I did the whole thing in Thermoshield. And my mother-in-law, who's moved in with me now, that's probably why I need a beer, is very happy.
Well, I think we'll go for a wrap up there.
Okay.
We should thank Charles very much. Okay, Charles needs a beer, so I presume you're going to join us at the pub down the road, Charles?
I'll race you.
Okay. We'll go out the door, down the ramp, the pub's just before the lights, there's an intersection down there. This is just one of BZE's activities, this discussion group. As I said before, BZE is into a lot of other stuff, and BZE is financially supported by donations from individuals. And where those individuals are regularly monthly donations, we call that a baseload support, which is kind of equivalent to continuously available electricity generation. We always need more baseload supporters to keep BZE going because we don't get any money from industry or politics, and that means we can research it and say the way it is. We're not beholden to anyone in what we release. So if anyone's interested, there's some information out there on the table, and we really appreciate your donations. We're also running Tech Tuesdays at the moment, technical discussions on all sorts of things related to all these sorts of problems at Kinder's House in Fitzroy, our headquarters. These are every second Tuesday, and if you're interested in getting into a discussion like that, please come and see one of us and look at the website. You can catch up with YouTube recordings of these evenings and download slides at the BZE website, bze.org.au/events/discussion group. The next discussion group is on Monday the 4th of April. The venue is here, and we'll have to watch out for emails to find out who the speaker will be. Thank you very much.